Hello everyone. If you watched the previous video about the transforms of periodic functions, then you'll have a good idea about what's going to happen now in these, because I solved similar examples, but they don't need a lot of details, but the process was shown. So here as well, let's do this over this f of t that is defined this way with as t when t is between 0 and 5, and 5 minus t when t is between 5 and 10, and we have the period to be 10. So this is a periodic function, kind of a continuous piecewise, and we'll go through the process. Recall what's written here in the other color and how to find the transform, and it's related with this Laplace transform, capital F on S equal to capital F on the period t of S divided by 1 minus exponential to negative S times capital T, or the period. So the first thing we will do is to find, we have f of t, the function, so we need to find the windowed version of it. Alright, so let's do that. So the windowed version of f of t, in order to apply the transform on it, is we're going to call it this f sub capital T of t, and we're going to use the kind of that rectangular form that we saw, and it's a formula. So now it is equal to the first part, which is t, times pi sub 0 comma 5 of t, that's for the first part, plus 5 minus t, the second part, times pi sub 5 comma 10 of t. Alright, so now we just go through the process of the formula. T, the window, the formula of it is u of t minus 0 minus u of t minus 5 plus 5 minus t times the second pi here will go as u of t minus 5 minus u of t minus 10. Alright, let's distribute t. This one is going to becomes u of t minus t, and this one is u of t minus 5 plus 5 minus t, distribute as well, minus 5 minus t times u of t minus 10. It looks like we have something to combine here in the middle, so t times u of t plus in the middle here, we're gonna have these terms with a factor of u of t minus 5, and let's bring in this one here down. Yeah, so you can pause the video and go through it and look at your notes and stuff, but we've done all these formulas so far. Then here it's just a matter of algebra, right? 5 minus 2t u times u of t minus 5 minus 5 minus t times u of t minus 10. Alright, so what we need to do now is to find kind of Laplace transforms on t, on the capital T of S. We need to sum, let's write it down, to find this part that we will need. We need to sum Laplace transforms of each term in the function that we found. And before we do that, before we do for each term, let's write it here. Before we do this for each term here, let's recall that Laplace transforms of f times t minus a, f of t minus a times u of t minus a on S is given by exponential of negative as times capital F of S. Alright, so let's just do that for each one. So you want to write them down and pause the video, then continue. Once you write them down, you continue with this next page. So we have Laplace transform for the first term. We have t times u of t on S. That's gonna be for t is 1 over s squared, right? And for u of t is just gonna be it's t minus 0, so the formula says as, so this is over s squared, so 1 over s squared. So the Laplace transforms of u of t is known, but if you maybe I can also give you that here as well. Let's give you that as well as in the review. So this is kind of a formula. Alright, and for this one, a is 0. Alright, so let's keep going. So what if it is completely different? I think I gave you that in the previously as well. But let's do it here. Let's write it down before we keep going with these. What is Laplace transforms if, and you have g of t, so it's not f of t minus a times u of t minus a, it's some g of t. Then u t minus a on s, then that exponential is there again. However, here Laplace transform of g of t plus a, so you have g and you put in a t plus a and you look, and of course on s, and you will look for Laplace transforms of that. Alright, so we have all these formulas, we just need to kind of apply them. So let's see, now I'll show you where we are. We did the first one, so we did this one. Now let's look into this one. So Laplace transforms of 5 minus 2t times u of t minus 5, you see, so this is g of t here, on s equal, so to this exponential of negative 5s, Laplace transform of this 5 minus 2t, I'm going to put in it 5 minus 2t, I'm going to put in it t plus a, which is t plus 5 on s, right? So let's just do the math now. So this comes up to be 5 minus like 2t minus 10, so negative 5 minus 2t, right? So that's comes up to be that here. So yeah, so we know how to do Laplace transform on that. We can do negative, the first one, negative 5 over s, and with the t is 1 over s squared, right? So now we're going to distribute that exponential, and we get negative 5 to the exponential part, and negative 2 with the exponential part over s squared. Yeah, so we can write it this way, or we can put the negative out and switch these to be positive. You will see what you need to do once you're ready to conclude this later on. Alright, but we got this now, we got this, so where we are now, let's see, this last part here. Alright, so for 5 minus t, Laplace transforms of 5 minus t times u of t minus 10, almost the same, not really the same, so we have to apply that g of t, so this is g of t. So you're going to do the exponential of negative 10s Laplace transform of 5 minus t plus 10, which is t plus a, right? So that puts you as 5 minus 10, which is negative 5 minus t. So this becomes negative 5 minus t. So we need to find the Laplace transform for that, which is going to be negative 5 over s. It's Laplace negative 5 over s, and the other one is negative 1 over s squared. So if we combine and combine using the common denominator, making a common denominator is going to be something like that. Then of course, so now we have the exponential part times this negative 5s negative s minus 1 all over s squared. Okay, which now if we send this distribute this exponential part here, And same thing, or if we need to put a negative outside, we can do the 5s exponential of negative 10s plus exponential of negative 10s all over s squared. Alright, so I think we finished the terms. We took their Laplace transforms. We're going to do their sum, and that's going to give us this Laplace transform sub capital T on S. Alright, so we'll just need to maybe I should do like I did with the other this. So now just to remind you before I do it, here is the first one, now 2 checks. Here is the second term, 2 checks. Here is the last one, 2 checks. So that's the ones I'm going to combine, right? But all these, so not lose track, what we did is we're looking for Laplace transform for this function. It has 2 parts or 2 rules. It is periodic, it is piecewise continuous. So we windowed this, then we followed that windowed version of it until we found f sub capital T of t, and that gives us 3 terms because we combined the middle, and these 3 terms we applied those special formulas to find each one. So the easier one is maybe the first one, then the other one had g of t. So even though it's completely different, it doesn't matter, we still can manage to do that because we just have a formula to follow. And now that I have the 3 parts, I just need to sum them. So here is the first one, here is the second one, let's put everything on one denominator because it's the same, and see what we can do with this thing. Suspect something, of course, is gonna be simplified here. And if you had a chance to do this stuff in the past, you know, those exponentials can also have some type of substitution or use substitution. Alright, so now I'll show you this looks like a long version of, but let's do some math on these to bring it to some nice form. So let's remember, if you watched the previous video, that if you have this, it means this negative 2 times 5, which could be also means this, right? So and in the previous video I said if you consider this to be a u, then now you have a u squared to be this exponential of negative 10s. Just a simpler way of looking at it. So looking at the numerator, you have, it's now becomes 1 minus 5s times the exponential of negative 5s, which means a u, minus minus 2 times exponential of negative 5s, which is a u, plus a 5s times exponential of negative 10s, which is a u squared, plus the exponential of negative 10s, which is a u squared. You see, now with the u is going to look nicer. So u squared minus 2u plus 1 plus 5s u squared minus 5s u, 1, 2, 3, 4, 5 terms. You're used to 4 terms do you factor by grouping, but when you have 5 terms, you can also look if it can be factored, right? So if it can be factored, I rearrange these so they are kind of just like a trinomial second degree, just like what we factor. So yeah, so if you look into this, this is something that factors. And so once I have this, I'm going to suspect, can I get u minus 1 here, right? So that's kind of the idea. So that's the goal. What do you think? Yeah, if we factor 5s u times u minus 1, you see 5 terms can be factored, not just 4 terms. 4 terms by grouping, direct. 5 terms rearrange, factor, look for something in common. So u minus 1 now is a common factor between these two, right? So let's factor u minus 1. And so now back, so this is the sub. So now back to, this is that, right? And if you saw the previous video, because of let's start here. Look at this one. This is 1 minus, not exponential minus 1. So just keeping in mind that idea. When we get here, we'll say, let's take it to that form. Of course, when you do this, you have a negative out. All right. And also this, I'm going to start with negative 1, but I'll take out a negative. Or let me show it first. Here first, so you see. Because I have a negative, I don't want it. Let's take out the negative here as well. So here I rearrange, I didn't do anything. Now I'll take out negative. So I'll have 1 minus this exponential minus this 5s exponential. And this is multiply 1 exponential 5s. Alright, so what happens here is I have 2 negatives. I can get rid of them. But because negative times negative is positive, and it gives me almost the final form. So these will go away, and I did get the form that I'm expecting to use it towards the end. So write this down. This is, remember, it's the numerator part that I try to work on and simplify. Numerator of what? It's this one here. This is the numerator. Alright, so I worked on that numerator only, right? So now I will put the new thing I found over s squared to give me this capital of F sub big T of S. Alright, so this is the numerator. Alright, so now we'll go back to the yellow. So we found that 1 minus exponential of negative 5s times this thing, 1 minus exponential of negative 5s minus 5 times s exponential of negative 5s all over the s squared. You see, now that's done. But this is not what we're looking for. It is related with the Laplace transform of the function f, which is what we're looking for is this. At the beginning I gave you the formula. It's and t here is 10, so it is what we found. All over s squared. Now it's over this thing, 1 minus the exponential of big T, which is the period, which is 10 of s. Now you suspect, of course. Look, what's this? Not this to a different color. So now you ask yourself again to simplify how. That's right. That's right. This one here, how it is connected with this one here. We know how they are connected, right? Because this 1 minus exponential of negative 10s is 1 minus exponential of negative 5s squared, which is now like a difference of squares. So if I use the u thing that I did in the past, so for you to see it, now that's 1 is 1 squared, so it's 1 plus u, 1 minus u. Alright, which means 1 minus exponential of negative 5s times 1 plus exponential of negative of 5s. So if I put that in the denominator, this is gonna go away, the top one. So now final answer is gonna be but what we had, right? Yeah, so this thing tests all our skills with this working with this exponential and substituting and finding the best possible way of simplifying. It's cool. All right, it can be done. So here, let's cross this, and that gives you the answer. Do I have? Yes. So pause the video again. So next page, I'm just gonna put this thing as the Laplace transform, which is another nice form for that. You see piecewise piecewise continuous and periodic and this and all that. All this can be represented with this Laplace transform here. So Laplace transform of f on s, which is the capital of f on s, is 1 minus exponential of negative 5s minus 5s exponential of negative 5s all over 1 plus exponential of negative 5s times s squared. Let's see, just I didn't forget the square. No, I didn't forget it there. All right, so now you see it's it's a more um, it's not hectic, it's more involving than other ones that we did, but it has a thinking process in it, which is good. That's what we try to do. And also it shows how far we can go if we have a certain application that is represented in a certain way and we want this transform, because as I mentioned previously, these have applications in whether physics or engineering or signal processing and other areas. And what do we do? Uh, we have everything established, so we just need this periodic function to window it first and work on this windowed version, then apply Laplace transform on the components that you get, or the terms or the parts that you get, using the different formulas that were established. And always you keep in mind the output, how it should come about. And once you have um, that capital F sub big T on S, then you will start to think about, if it's a of course you have a bunch of exponentials, sometimes this work repeats, and you get used to it, and you suspect that you have the u substitution there to make it easier. Yeah, and once you find that, then you have the formula that relates everything, which is the Laplace transform, or capital F of S equal capital F sub big T on S divided by 1 minus exponential negative S times the period. And yeah, and you just do a substitution. Then you see, is there anything else I can simplify? And we saw in this example there is a difference of squares, and it simplifies. So I'll do some other example in another video. Thank you.